So this is a little video with some thoughts on my Clarke 130EN turbo MIG welder. It's a gas or no gas MIG welder. I got it originally because I was working outside on my Range Rover Classic, and one of the advantages of so-called gasless welding is that you can use it outside because the shielding gas doesn't get blown away in the same way that a conventional one would. Gasless MIG welding is a bit of a misnomer though, because there is still a gas. It's just generated from the wire, which is called flux cored wire. When the arc is generated, the gas is generated from the wire, and that shields the weld in a similar way to a conventional gas supply. Generally, I found gasless MIG welding a bit heavy going. Like I would get there in the end, and certainly the penetration was fine, but it tends to be quite messy compared to conventional gas MIG welding. And certainly, well, I found two things. I found that you tend to get a little bit more burn through, in my experience, I think because it tends to run a bit hotter, but also getting the consistency in the pools was a bit harder. Part of the reason for that, I think, was that gasless welding tends to generate a bit of a sort of fine, like, deposit on the surface of the metal. And I was finding this was interfering with the arc circuit a little bit. So I'd be going along a seam quite happily, bzzzt, 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 and then all of a sudden, like, the wire would stop arcing. And I think that's because it was kind of touching the kind of thin deposit on the top of the weld seam rather than the clean metal underneath. So I'd have to stop quite regularly, clean everything up with a wire brush, and then carry on. And I think that sort of constant interruption of the process was kind of making, you know, you'd struggle a bit to get the consistency in the seam. So I just, you know, I'd get there in the end, but I was spending quite a lot of time grinding, filling holes, all that sort of thing. So now that we're inside and working on the Mercedes, I've got the gas conversion bits for it, and I'm going to give this a go with the gas supply. So to convert one of these to gas, you need to change the polarity on the earth. I forget the technical reason why, but that's relatively straightforward to do. Just flick these around on these little plastic knobs with the thread. Obviously, you need a conventional welding wire, and you need a gas bottle. Now, to get me going, I'm just going to use these like disposable gas bottles that you can get like in Halfords or Machine Mart or whatever. I think longer term I will go over to a larger refillable bottle, but for now these will work just fine. Most people seem to recommend for kind of general automotive work like a sort of 15-85 argon CO2 split, or perhaps 80-20, whatever. When you get up to maybe welding slightly larger thicknesses, bit more CO2, it'll just run a bit hotter, is sometimes recommended, but for my purposes that's absolutely fine. So the gas bottle just goes on the back here, just goes through as a sort of little tie strap. I just put a rather large cable tie, hold it in the sort of indent at the back here for it. And you need a regulator. The supply pipe to the welder comes with it. Now, one thing I will say about the regulator is I found the standard regulator that Clarke sell you for these is a bit rubbish. Like, the thread just doesn't feel very positive to me. The numbers don't really seem to sort of match up with the flow. Like, you can you know when it's open or when it's closed, but kind of between the two you can't really tell what's going on. So I got this slightly more expensive regulator thread from Halfords this morning. It's an SIP thing. It still doesn't have an actual gas flow gauge on it, which I think is something I probably will get in due course, but the thread just feels like slightly better quality. Like when you put it in a position, it sort of actually feels like something, you know, it feels more positive. So I'm going to put that on in a moment and see how I get on with that. I found with the 0.6mm wire I put in initially, I found on the kind of mid-power settings, it was just snapping in the wire feed for some reason. I don't know if that's a current issue or whatever it was. When I turned it down to the lowest current setting, the issue seemed to go away. But I've got some 0.8 wire as well, which I think I'm going to fit before I start again on the Merc. Partly because of the issue with the 6mm wire that I seem to be having, but also because for some of the heavier welding, a 0.8mm wire is just a bit better anyway. Just gives you a little bit more weld wire there to work with, and that will also allow me to use a slightly higher current setting. So overall, I quite like this welder. Like, I'm not too worried about, you know, the sort of relatively short duty time that you get compared to the larger, in more sort of industrial welders. If I need to let it cool down or something, I just go and, you know, have a cup of coffee or whatever while I'm waiting. The only slight disadvantage that it compared to some of the more expensive welders that I've used is that the current settings are relatively binary. So you've essentially got 4 current settings, which are defined by a sort of combination of these two-way switches. And what I just found on the Range Rover with some of the thinner metal is that even like the lowest setting, albeit without the shielding gas, it was tending to burn through quite a lot. Now I'm hoping that with the gas that will be less of an issue, but even so, if you got a more expensive welder with more features, you'd be able to just turn the current down that little bit sort of more. But other than that, it's a perfectly acceptable welder for kind of home use, as I'm doing, and it seems relatively well built. Okay, the wire feed and stuff's a bit sort of, you know, a few bits of plastic in there, but yeah, for now at least it does the job. See how I get on with the Merc, and I will report back in due course.